Were there questions on last night's homework? How was everybody on that? Hey, why before you don't go away? It was just all the vocab stuff, right? You guys were okay with it?
Yeah.
Yeah, I didn't want to like get into it until we were done. Because then it's like that one thing that I didn't teach is what shows up. It's like, ah.
Yeah, the cosine stuff came up.
But you should already know cosine, so I mean I'm not even worried about that. Oh, where are we at? Anyone remember where we were at?
I think.
Did we do cosine?
No, we haven't done.
We did sine.
Hold on. That's the last. I think that was our last problem that we did.
That's sine. Okay, so here's just a quick one for cosine. Thank you. Welcome back. So continuation, we're finishing off 4 or 5. Here's your information for cosine. Cosine should start at.
That's sine, dude.
That's not right. Cosine should start at 1. So your graph for cosine, if you remember correctly, what were our values here on our unit circle? We had 1, 0, 0, 1, negative 1, 0. Oh, that's driving me crazy. The shaking. You don't see the shaking? Look, and the closer you are, the more. So my eyes are like literally bouncing everywhere here. So 1, 2, 3, 4, and of course we're going to be at 0, pi over 2, pi, 3 pi halves, 2 pi. Now we're talking cosine, so it's still a unit circle. So we're going to go from. So what's my range on cosine? Oh, we shouldn't ask that question yet. Let's get started. How? I'll use a green. So it'll go negative 1, 0, negative 1, back to 0, and then back to positive 1. So we're going to look something like this. So it looks kind of like a C on its side. That is 1 period of pi. What is the period? 2 pi. What's the amplitude?
1.
What's the range?
Negative
1, 1. What's the domain?
Negative infinity,
Negative 50. You guys are good. You guys make me look good. Amazing. I wish this was my math class every day, all day. Like, I'd be like,
Why do I feel like that one was so loud?
I don't know. Someone made a comment. I don't know what it was, but it didn't sound too good. Would you guys go crazy? Is that what it is?
Yeah.
You would love math.
I feel like math class, no offense, should be like 20.
You know what? I agree.
You agree?
I agree that
At least 30.
I should only lecture for about 20 minutes. And then the rest of the time you should be exploring. But we're so outdated in our models for teaching that it's kind of hard to get into that. Doesn't mean that we're not trying. But yes, I don't disagree with you. Snapchat and YouTube mess you all up.
Snapchat, YouTube.
Y'all can't pay attention for more than like 7 minutes at a time.
Alright. I can do it if I'm not crying. I can do it if I'm not. I'm tired.
Oh, feel you, Lily.
Huh?
I feel you.
I'm tired of lecturing me. You know it.
I don't.
Okay, moving on. So let's see here. I want to make sure I don't miss any information. Same ideas as before, guys. Phase shifts. They have that weird formula that they want you to use, but it's easier if you just factor out B if it's out there and take a look at what the phase shift is. Period is still 2 pi over B. Amplitude, absolute value of A, hasn't changed any of our stuff here. So, for this part, what's our amplitude?
3.
3. What's our period? Be careful now.
Pi over 6. Negative pi over 6. Positive pi over 6.
It's just pi. It's pi.
It's 2.
What? It's just pi.
It's going twice as fast.
I thought that.
Oh, 1 half?
Is it 2?
Isn't that B?
Pi.
That's B, right? So it's going twice as fast, which means my period is now pi. Okay?
If only Genevieve had to say that 19 times.
I hear her, but like I don't want to like good. Like, I know, I hear it, you're okay. Okay, so yes, good. And I really do, like, I don't want to, like, okay, good, let's move on, because some people are struggling with the idea. All right. Here's the harder question. What is the phase shift here? Did it move left or right? To the right, how much?
Pi 6.
Oh,
Pi
yeah.
6.
Yeah.
Pi 6. Okay. Now, let me show you what I would do. I don't like having B inside here. I like it having it up front. So here's what I'll do, Sonny. I will factor out 2 because I can clearly see that's B. That leaves me with X. But I got to think about what this is going to become. So the easiest way to do it is to take what's already there, that negative pi thirds, and then divide it by B. Okay, so when you do multiply, it ends up being this, and you're going to get negative pi sixths. And that's the phase shift.
Yeah, like that, their rule that you showed me yesterday worked for me a lot better. I don't know why. It would work for me a lot better.
Cool, then,
Dividing it by the division.
yeah. And that's what I just did right now, too.
Wait, yeah.
But I see it differently.
Yeah.
So if that works for you, keep doing that. Okay? What else are we missing? What's domain here? What's the domain?
I mean, infinity to infinity.
The domain?
Yeah. Well,
No.
Negative infinity to positive infinity.
Okay, that's like.
What is my range?
Should be.
yeah.
Negative 3 to positive 3?
Yeah.
Cool beans. Let's move on. Yeah.
Graphic.
That was deep. Okay, here's all the points that are relevant for cosine. And yes, it's just repetitive. Its period is 2 pi. Ranges from -1 to 1 unless we've stretched it or compressed it. That depends. How do I know I've compressed it?
If it's less. If it's in between 0 and 1.
A should be between 0 and 1. Good. All right, moving on up. Here's some more stuff. Cosine is an even function. Please remember that. Sine is an odd function. Cosine is an even function. All right. These graphs, please be careful, because the word for these to describe them is sinusoidal, and it sounds like they're sine curves. Yeah, but they could be cosines and they could be sinusoidal. They're not cosinusoidal. Sinusoidal just means that they are wavy and repetitive forever. Okay? So don't think that because it's a cosine function, it's not a sinusoidal graph. It's not, I can't say it, it's weird. I almost feel like I always think just like sinus problems type stuff. Right? Sinusoidal. I mean, it's in there, sinusoidal. Sinusoidal. Okay? Questions on this slide? Oh, and I was saying that a minute ago, right? And I think this is what they're expressing as well. If you take the cosine function and you shift it over pi halves, it is exactly the original sine function. So, here's what I'm saying. I'll repeat it. If I were the cosine of x is equivalent to taking the sine of x and shifting it pi halves. They will look exactly the same. And that should make sense, right? If you think about the unit circle when you started, the numbers would match once you skip that first 90 degrees. Okay?
Yeah.
All right. Where are we at? Moving on? I can change it? Cool. More of the same. We already did amplitude. We've already did period. Okay. I've got a function here. It's y equals -4 cosine pi x. Ooh. What is the amplitude?
4.
Nice. That was quick too. 4. Why not -4?
Because it's the absolute value.
Absolute. It's the absolute value. Ah, absolutely. What is the period of this thing?
It's gonna be pi. No, it's gonna be 1. What? It'll be 1.
I'm going to do that from now on.
No, that's.
Is it
It was a little awkward though.
Yeah,
Hang on, there's a pi in there. B is pi, right?
Okay.
So by 2
So what's the period?
2.
2. So now you've gone from the weird pi stuff to actual whole numbers. In this case. So watch out for that. And then they want us to graph it. I think this might have been a giveaway too, right?
Oh yeah.
They went from -2 to 2.
I
I didn't even think about it, but okay. All right. Do we need a graphic? You guys are okay, or let's move on then. All right. So this is more of the same. I feel like I already did this slide. Okay. Take a look at this equation. What's my amplitude? 3/2, aka 1.5. What is the period?
It'll be 2. Wait, no. It'll be pi.
Pi is my period. What is my phase shift?
It'll be
Pi halves. Pi halves. So another way I could have written this is 3/2 sine 2x. Right?
Yeah.
Ah. Okay. Just a side note. That's not even important. Just being silly now. All right. Cool. So we're good. Questions on amplitude, period, phase shift for this guy?
No.
Anybody? Which part? Okay, let's talk about amplitude. You're okay with it?
Yeah.
Okay. Period. What's my period? It's 2 pi over b, right? So the 2's would cancel, you get pi. Now the phase shift. I moved it, right? So what you're going to want to do is take pi and divide it by 2. And that's pretty much it. You're not seeing that part, are you? Okay. So let's kick it out then. Okay. 2 times something gave me pi. 2 times something gave me pi. So if I take pi and divide it by 2, I'll get back what was there. Does that make sense?
Yeah.
So that means that what was originally here was pi halves, and that's my phase shift. Is that a little bit better?
Yeah,
Okay. Okay, cool. To the left, pi halves. Also, it probably wouldn't match. So that was a lie.
Yeah, what is that?
It probably wouldn't match. All right.
Oh yeah, that was in the homework last night.
For sinusoidal graphs of the form, what is this, guys? These are just sine and cosine, right? With everything in it?
Yeah.
Instead of C and D, what do we call them?
It's
H and K.
And then the maximum.
Let's see, the constant D causes a vertical shift in the graph.
Oh, heck, that's a cool idea.
Okay, so what they're calling this,
Is K.
how do I want to describe this? Oh, simple enough. Okay, so let's do this. So here is, let's talk about this, okay, real quick. You guys okay with that? That's just me trying to graph something. And let me start with this graph. What did I just draw there? Technically cosine, or if you want to be smart about it, you shifted sine over pi halves. So, does everybody agree that the x-axis is technically cutting this sinusoidal graph in the middle?
Yeah.
Okay? Could we agree that we can call that the midline? So this is the equation to the midline. In this case, my midline is y equals 0, right?
Yeah.
But if I were to add a k or d, what they call it in this case, so if I were to shift it up 2 units, so if I did y equals cosine x plus 2, that means that the whole function is going to shift up 2 units, correct? So what would happen is over at 2, I would create a new imaginary midline, right? Everyone okay with that midline moving up because of the plus 2? Then the graph would all just kind of do this bit, wouldn't it? Okay? So what this is simply the equation. Thank you. So y equals d is simply the equation to the midline. And it should be equivalent to that vertical shift. Because you're kind of taking 0 and you're moving it up 2 units. So that midline shifts up 2, shifts down 3. It's a really good way of figuring out how you're supposed to graph a line. Okay? So if we go over to something like, and that's what this is really. If you think about it, if D is the midline, don't I go up A units and then down A units? That's all that this is saying.
Why do you go down?
Because of my amplitude, right? If my amplitude was 2, how far up do I go? That's this.
Oh.
And if I go, and then I would also have to go down 2 units, right? So this is saying from your midline, go up 2, and then go down 2. There's your range. Okay? So your maximum value is that, and your minimum value is that. So even though you could see it visually, they're kind of giving you formulas here to find the max and min. Because the maximum would be at the, what's the word? The cusp? No, there's another word for it. Anyways, the very top. I'll find that word and I'll use it and I'll sound smart. Or not. Or not. What is this? Oh, okay, so we're going to do this line up there. Y equals 2 cosine x plus 1. Let's do a new slide. Y equals 2 cosine x plus 1. So, is there a phase shift? There's no phase shift here. Is there a vertical stretch or shrink?
Yes.
Yes? What is it? Which one? Which one? Stretch or shrink? Stretch by 2. Okay, cool. So here's what we're going to do. Originally, my line, this would be my midline, correct?
Yeah.
But my midline has been shifted up
1.
1 unit. So I'm going to draw me a new midline. Okay? That makes sense?
Yeah.
And my max is going to be 2 units above that, correct?
Yeah.
So that means my max is going to be 3, and my minimum will be -1. Good, you see it, right? Now this is a cosine function. Where does cosine start at? Does it start at 0 or does it start at 1? Starts at 1, right? So I'm going to go to my max, which is technically my new one, and I should have 1, 2, 3, 4 points because there was no stretch horizontally, correct? So this should still be pi halves. This would be pi. This would be 3 pi halves, and this would be 2 pi. Okay? So here I've got this. Then I should go down to the midline and get a 0, shouldn't I? And at the next point, I'm going to have a minimum, which is right here. Then we're going to head back to 0. And then we're finally going to go up to the top at 3. And now I can... And there's my new graph with everything in there. Okay? But it was easier for me to see it with that midline. Because now I treat that like my x-axis. And I'm throwing air quotes for those that aren't looking. But that's it.
How did you know it was going to go down?
Because I know my midline is at 1, correct? And how far up and down do I have to go from there? So I just went 1, 2, 1, 2. And that's what the last slide was saying. Your max will be at D plus the absolute value of A, and your minimum will be at D minus the absolute value of A. Now that's exactly what we just did.
Yeah, I didn't put it together.
But now you did.
Yeah.
Good. How are we doing on that? You guys okay with that transformation? So
I think the only thing I'm having trouble with is
phase shift? Yeah. And I'll tell you, dude, when I was in high school, I struggled too. I struggled too. But hopefully in the math lab, it'll be nice where we can kind of see those points because they'll have these graphs for you already, and you'll be able to do that. All right. Can I change the slide now? Didn't we just do this?
Yeah.
Okay. I think we just did that too, didn't we? It's exactly the same but different. Alrighty. Okay, what is this? A region is 30 degrees north of the equator, averages a minimum of 10 hours of daylight in December. Hours of daylight are a maximum of 14 hours in June. let X represent the month of the year with 1 for January, 2 for February, 3 for March, 12 for December. If Y,
This is a lot of information.
it is.
I don't know how to put it together.
Well, we're gonna have to break it down. But this one thing that we struggle in math is reading through these problems, which is funny because I think these are as close as you're gonna get to real life type stuff,
And we don't know how to do it.
and we don't know how to do it. But that's what we ask for all the time, and we're like, hey, we're problems, but teach me what I'm gonna do this for real. All right. So anyways, so they're asking us to use numbers for the months. If Y represents the number of hours of daylight in the month, X, use a sine function. So we know we're using sine function. Y equals A sine BX minus C plus D to model the hours of daylight. Because the hours of daylight range from a minimum of 10 to a maximum of 14, the curve oscillates about the middle, somewhere about the middle value, which is 12 hours, thus D is equal to 12. So what are we supposed to do? Draw it? No. Right equation, right? So let's break this down. If D is equal to 12, then that means that our K, what we call K, is going to be 12 at the end, correct? Yeah. And we know that it's going to vary up or down depending on the number of hours. So what's going to be my A value? 12. 12. Right? So we got 12 sine something. I should put more space in there. Oh, thank you. Yeah, I was like, what was there? No.
But it says plus 12. That's why I said.
Oh, it is plus 12. Yeah, so 12, yeah, because it goes up 12 and then it goes down. Okay, we're good. Okay, so. No, because look at the maximum and the minimums. The maximum is 10, correct?
That's why I said it. Would it be?
What? That doesn't make any sense. How do you put that together? If that doesn't if A has to be. That seems right because then A has to be.
Hold on, shh. Let's do one person at a time so we can hear everybody's perspective. Let me get rid of, I'm pretty sure about 12 being D because, I mean, you can't get any clearer than that, right?
Yeah.
Okay. We know that the maximum number of hours.
Wait, hold up. 12 plus.
Can't you work in reverse? Like,
Yeah, like, like yeah, because if it's plus A and then it's minus A, what did you like?
so it has to be like plus 2 and minus 2?
It would be 12 plus.
Okay, hold on, one person at a time.
That'd be
Let's use that universal sign for I have something to say. Go ahead.
So if you put it into like the D plus outside of A, it has to be 2.
So if we're using the formula for D plus the absolute value of A, and this equals 12, and we're saying that the maximum
No,
is
you
10.
put that equals 14.
Well, D is 12.
No, right?
Yeah, because this would be, so we're using the formula D plus absolute value of A is equal to something. We know that D is 12, and the maximum is 14. So that means that absolute value of A is 2. Does that work the other way as well?
Yes.
Yes, it does. Okay, good. So
But could it be negative 2 or
Could it be negative 2?
it could be, because we're doing the absolute value of both. But for now, let's do 2. For now, let's do 2. Okay? So we have that. Did that make sense, honey? Okay, good. Now, let X represent the number of hours. So with 1 for January, 3 for February, 2 for February, 3 for March. So that's looking like, and 12 for December. That 30 degrees, I feel like it's going to give us a horizontal shift. Okay, we've got 2 things there to worry about, which is going to be a phase shift and a horizontal stretch. Take a look at those. See what we can find. Actually, turn to your elbow partners. So let's do that. And I'll take attendance because I think I forgot. No, Yancy?
No, Yancy.
Please have the discussion with your elbow partners.
Okay.
Don't look.
Trying to figure out.
Two things, space shift and horizontal stretch.
Just wait. Don't we already know? No, we don't. Never mind.
I didn't want to take. You and Gunner are. I didn't want to take.
Oh yeah.
I think that 30 degrees is going to have something to do with our phase shift. With our phase shift. Is this my last slide?
You can turn it over.
Oh, okay.
Oh, that was interesting.
Well, yeah, I don't know.
No, I'm telling you. I knew it was two.
Okay, so maybe
I like
you
when you
can
have
use
this
it.
round. So she's like,
Let me just like.
I didn't do. Like I was gonna be like, when I was eight, like I went back. I did not.
Oh, this it's sine 30 sine degrees. Yeah. And it says in December it has 10 hours of daylight. And then it goes June 14 hours. June 6. Well, oh, 12 is half, 6 is half of 12.
I don't forget do 30.
Oh. Would it just be?
No, for real though, what? Hey, y'all know something? I could
What?
say casino. I knew.
From cosine to
No idea. And then I said two, and it was like 12. And then Sumi, wait. They got me white. And then she played I didn't wait your like 4 years.
So would it be, since it's only 30 degrees, would it be pi over 6? Because that's what it is, right? And then,
And now I don't know. I don't know if you how do you even convert 30? You convert it?
Yeah.
yeah, you convert it, you convert it to pi over 6.
It's a radian.
Oh, wow. Guys, I just want my genius in here.
December hour, daylight's maximum 14 hours in June.
Okay.
Extra
So that's where it is.
by 1.
Okay, so.
X.
Anybody got any ideas on B
No.
or the phase shift?
I've got the phase shift would
Wait.
be pi over 6 with 30 degrees, but the thing is that
Hold on, what? Say that again?
the phase shift, wait. Yeah, I got 30 degrees of that, like
Pi over 6.
radian. That's pi over 6. But in
But Yeah, but she's right. That would be
Okay,
where your
for
phase
starters.
shift is at.
Let's think about a period of this, okay? Technically, you know, how long is it supposed to be going?
Yeah.
Typically, think about this realistically. Typically, what would a period have to include as far as that calendar there? Because they kind of gave us some hints there, right? It has to be 12 months. So that means that B, say that, go ahead.
Wait, wouldn't that mean that like it'd have to be 5, 6 because
B is my period, correct?
Yeah.
What, hold on, why would it have to be pi 6?
Why?
something in there has to be for the period has to be like 5, 6 because
Hold on,
go around the whole
this is wrong. The period,
when you go around the whole circle, there's 12 like spots.
Yeah. For
Ah,
5 or 6 is
smart.
12.
smart. Or we could think about it in the formula, right?
Yeah.
The period is equal to 2 pi
2 pi
over B.
B, yeah.
And what did we just say that B was?
12.
12 months.
Yeah.
So this becomes 12.
So then it would become.
Then what's my period?
Pi over 6.
Pi over 6, right? So that means that now we've got y equals, maybe I'll write it up here. Y equals
What?
2 sine pi over 6. X goes here.
Remember the period thing is
Okay.
2 pi over B?
Now we just need to worry about the phase shift.
Which.
Okay? Well, now we need to worry about the phase shift. What do you got for phase shift? Go ahead. Yeah, because remember, a whole cycle technically is from January to December,
Well, you
right?
put your 12 on the outside like it was K. And then you put pi over 6 where B is supposed to be.
So say that again?
You put 12 where K is, up there, and then you put pi over 6 where B is.
Did I put it backwards?
Yeah, because remember B is, yeah, B is 12. Remember 2 pi over B, and then 12.
Here's our period.
Yeah, but remember period is 2 pi over B. And we're-
Right.
And so you put, that's your B, right? It's,
No, that's K.
I thought.
That's our up and down shift.
Yeah, but you put pi over 6 here, right? So take
Yeah, I could put it in front of X.
Yeah.
I could put it there, but remember my preference? Go ahead.
So you're saying how B is 12, so then why are you just writing pi over 6?
Period is defined. The period is defined as 2 pi over B, correct? 2 pi over B. And we know that B is pretty much how fast it's going, right?
Yep.
How long does it take us to go through a whole
Year.
daylight cycle thing? It takes us to 12 months, correct? So B becomes 12. Should become 12, which simplifies to be pi 6.
Yeah, like when you put like the 12 outward sign.
Am I writing my formula correct?
I don't think so.
No, you're correct. You're correct. Hold on. I wrote it backwards, didn't I?
Yeah.
So B is equal to. Hold on. I just looked at it. Period is 12. And we're after B.
Yeah. So then
That's the way I should have written it. It turns out it's the same thing because you got to multiply both sides by B. And then you got 12B is equal to 2 pi
when you divide by.
divided by 12. So I end up getting the same thing, but I did write it wrong. You're correct. I wrote it wrong. So B is pi 6.
And technically you're right.
Okay, now, what we need is a phase shift, correct?
Yeah.
Okay, what was phase shift defined as? Remember we just took this value over this, the B? So if I took, can I get rid of this work for now? Just make some space?
Yeah.
Because I think we're running out of space here. Alright, let's see here. So, our phase is defined as this spot, which they called C, and dividing it by B, correct? And we already know that B is pi 6. The question, though, is what's our phase? What is the C value?
I think you have to plug in
I think it's still pi 6.
because it gives you two things. It says 14 hours
And
is the maximum for 6 if when 6 is x is 6. So what if you plug it in?
Wait, what?
Yeah, that helped us with getting.
Oh yes, no, he's talking about a maximum of 14 hours in June, and June is the 6th month of the year.
So what if you plugged in that value?
So
So y would equal 14 and x would equal 6.
Yeah, xm would equal 6.
so the maximum number of hours is in June.
So we're trying to find the minimum, right?
So if it's sine, where does sine start at though at the beginning?
Sine starts at 0.
It starts at 0. So is June that we want to pick?
No.
So is June the month we want to pick?
I mean, if we do that, it would.
Right? So let me do this real quick. No, it was good. It was good. It was great. So we know we got 1, 2, 3, 4, correct?
Yeah.
So technically this would be Jan.
Yeah.
This would be March. That's sorry. That's not an M at all. Right?
Yeah.
January, February, March, April, May, June, July, August, September, and this would be December.
Yeah.
Okay? So going with what you just said, we know that June has this, correct? Max?
Yeah.
So that means this would be here, and then we would be here? Correct? So we would have a curve that looks something like this. Right?
Yeah.
But now stop and think about which function are we working with?
It said sine.
Sine, right?
Yeah.
What if, I thought January would start at 0.
Yeah, that is 0. This is Jan.
Yeah, but
Put your dot down there at the bottom instead of at 0.
why is it negative?
Because this is June, correct?
Yeah.
And June was the max number of hours, which is 14.
Oh, okay.
So I got to follow that sine pattern. It has to. But that's a fantastic point that you just made. Shouldn't sine start at 0?
Yeah.
So that means this is my 0. So when I shift it, now it would be there, wouldn't it? So what's my shift then?
It'd be pi
We lost you?
over 2.
The 3rd month, which is March. So what do we call 3,
Pi 4.
No.
3?
Because
Yeah, it is.
Yeah, it is.
But are we in pi though? Are we in pi?
Yeah,
Yeah.
because that's the radian.
Yeah, it's the radians. It'll be pi over 4.
So okay, so what did we shift? How much is this distance from here to here?
That's
Pi halves.
I thought it was pi 4.
No.
No, because
No.
it's just.
This is, it's a normal period, right? 2 pi?
Period, 2 pi.
This is pi. This is 3 pi fourths. This would be pi halves. So we just needed to get March to move over to here. So our phase shift is pi halves. Why would it be pi sixths? We're doing it in quarters. Okay? So, going back to here. Wait a minute, we are here. Going back to here.
Yeah.
Then our phase shift would be, what did we say, pi halves? So this would be one version of the equation. Go back. Go back.
There you go.
I hate, see now. Okay, so this would be one version of it, and our other version would read y equals 2 sine
Pi 6x.
pi x 6
Yeah. Plus.
plus, whoa, pi squared 12, right?
Yeah. Yeah.
Okay,
It's there.
there's our model.
Terrible.
I just distributed, Ernie. I just distributed. Go ahead.
How do you get from 12 months of the year to pi?
Okay, so here was my sketch, right? And remember what I told you? We always go 1, 2, 3, 4, because it's easy to see it in fours on any one of the functions, right? Whether it's sine or cosine. And what we said is let's designate this to be January,
Do I know him?
and then the next quarter would be in March, right? And then we would be in June, September, and then December, correct? In quarters? Correct. So it goes, no, it's threes. So it'd be, 12 months. So 3, 6, 9, 12 months. So we're good so far? Now there was a key detail in here that Ernie brought out, brought up that said our max is in June. See that 14 hours? That's the max. So if I go back to my graph, in June, I should have a max at 14. Correct?
Oh, and then you just draw it from it?
And then from there, I know how it's supposed to behave. It's got to come down. It's got to do this. It's got to do that. But because it's a sine curve, my first zero should happen there. It's a sine curve, correct? Does sine start at 1? Or does sine start at 0?
No,
Oh.
Okay.
I understand.
Go ahead.
If it says the point is on June, it's on the map.
Yeah, that's what I was gonna guess too.
Oh, you're trying to find
The phase shift. Yeah, so in order to get this to look like a real sine function, this whole graph needs to get shifted to start there, right? Yeah, it shifts all the months as well. So now Jan would be like out here somewhere, and then March would be here, June would go there, December would go there. But now it looks like a sine curve. So the question was, how much did we have to shift that whole function? What's pi halves? Because remember, the whole thing is 2 pi, right? This is 2 pi. This is pi. This is pi halves. So this distance is what we had to shift it. Right. To the left, which means that this should have shown up as a, I keep going there. So here's why we showed it as a plus halves. So now we've got all of it. And then to do the other version, to do the blue version, I just distributed that pi 6. That was a beast. Good stuff though.
I don't want to do it again, but I can.
We'll do it twice. I'll put it'll be like 5 of these right here.
I don't like that. I mean,
I
I
can't
do.
hear this question. Can we quiet down a little bit?
So like when you're doing polynomial on the graph, because like you know how it behaves, so you know
My friends are freshmen.
I don't know if I understand the question. So you gave me an example?
And so apparently I stopped sitting higher because apparently the overload. You see what I mean? And it's like totally like I treat Kate as like a
Well, we don't know exactly what they are. We're going to use that unit version, aka radians. Technically, we don't know what units are here, do we? And that's why we're in radian mode. We're in that units thing that we should know.
I know, right? People like freaking stitch my pants off. I need another pair. Look at it.
It would have to. I think that the more we see them, they'll become clearer as we do it.
What?
And that's why we were able to shift it so it looks like a real sine function.
I mean, hey.
That's it? Any questions? That was a lot to digest.
Yeah, that was a really big. That was a good problem. Though. I liked it.
I think that's going to be like our team stuff.